Okay, this is part 2 of the video angles and their measure. And the first thing I want to do here is do just a couple of little definitions that you should remember. The first one is central angle, and I need you to be sure you remember that a central angle is an angle whose vertex is at the center of a circle, and that the rays of the central angle subtend or intersect an arc on the circle. The word subtend is just a mathematical word that means intersect. So a central angle is an angle whose vertex is at the center of a circle and whose rays subtend or intersect an arc on the circle. Now, the next thing that I want you to know is the definition of a radian, and we're going to do a little bit more with this in the next lesson, but I do need you to know that if the radius of the circle is r. Okay, so I'm going to draw over here because I know sometimes it's hard to see it just from the picture. So if I have a circle with a radius of r, okay, and the length of the arc that is subtended by the central angle is also r, so this is radius r, and if the length of this arc that is subtended, this arc right here, that is subtended by this central angle, and we'll just label it theta, if this length from here to here is also r, then the measure of the angle, the measure of theta is 1 radian. Okay, so if the radius of the circle is r and the length of the arc subtended by the central angle is also r, then the measure of the angle is 1 radian. Notice from the picture that it doesn't matter how big the circle is. We've got 4 different sized circles here. We've got on the left, you've got a medium-sized circle. On the right, you've got 2 concentric circles, one small one in the middle, one bigger one on the outside, and then you've also got the one that I drew over here, which is a different size. But all of the central angles for all 4 of these are 1 radian. In the circle on the left, it looks like my circle. The radius is r and the arc length is r, so theta is 1 radian. In the circle on the right, the smaller circle, the radius is 1. The arc that's subtended is also 1 unit long, so that angle is 1 radian. In the bigger circle, the radius of the circle is 3, the arc subtended is 3. That angle, which you can see didn't change in size, is still 1 radian. Oh, I went backwards, my fault. That was yesterday's lesson. Okay, now from this we need to be sure that we understand and know the theorem that is the arc length theorem. We're going to be using this quite a bit. For a circle of radius r, a central angle of theta radians subtends an arc whose length s is s equals r times theta. S, which is the arc length, is any convenient unit of length. It might be inches, it might be centimeters, it might be miles, it might be kilometers, it might be meters. Any convenient unit of length. R is measured in any convenient unit of length. So the radius can be centimeters, inches, kilometers, meters. Those 2 units of length need to match up in the problem. So if S is measured in inches, then R needs to be measured in inches. Theta, however, is always measured in radians. So this is saying S equals R theta, where S is the arc length, R is the radius of the circle, and theta is my central angle, in radians. This must be in radians. So if it's not in radians, then you can't work with this until you change it to radians. And we are going to talk about how to do that. Okay, so at this moment we can find the arc length of a circle of radius 4 meters. So my radius is 4 meters, subtended by a central angle of 2.25, 2 and 25 hundredths radian. So we need to employ our arc length formula because we're looking for the arc length. S equals R theta. So S equals 4, that's my R, times theta, which is my 2.25. Now we are very lucky here because we can see that our theta is in radians, so we don't have to worry about this. We can just multiply these two together. So S is 4 times 2, and this is how I do this without my calculator. 4 times 2 is 8, and then 4 times 0.25 is 1 more, so 8 plus 1 is 9. Now the unit of length here is the same as my radius, so this is 9 meters. So my arc length is 9 meters when I have a central angle of 2 and 25 hundredths radians that subtends this circle of radius 4 meters. All right, that's all for today. This takes care of angles and their measure, and we'll come back tomorrow and look some more at radians.